Good morning, everyone. I'm going to go ahead. I just graded through this assignment. This is the custom assignment 5.1. Oh no, custom assignment from 5.1 on target 7.3. I wanted to walk through this. I saw a lot of students doing a lot of good things, and then I also saw a lot of confusion about this reaction. And I will admit, this is probably a little bit more on the confusing side, so I can definitely sympathize here a little bit. But let's go through this and see if we can figure out what's going on. So the problem requires you to have watched the video. So I'm hoping you've had a chance to actually watch it. I can't check that, but I'm assuming you did. But if you watch the video, what you'll see is we take a piece of magnesium, this silvery thing right here. When you watch it, the normal version, you can just tell it's like a silvery metal. And then this is the thermal camera. So in the thermal camera, we see that the metal is going to go into this flame. And what's kind of interesting about this is that the flame, we know, like in real life, it is pretty hot, right? Fire's hot. But look at what it looks like at this thermal camera. It's kind of a dim pink. So if this is, flaming hot, then what must this be? This must be very, very hot. This has to be significantly hotter than this. Look what happens to the flame when we do that. And that's going to be important in our LOL diagram because we are not just warming this up to the temperature of the flame. We are getting it even hotter than that. So, for example, if I were to take a pan and put it in the oven, the pan will get to the temperature of my oven. Well, the magnesium's not doing that here. The magnesium's not just getting to the temperature of the flame. The magnesium's getting much, much, much hotter than the flame. So something else must be going on here. That's, by the way, why this question was the first question, is I wanted you to pay attention to that flame, and let's see how we're going to draw it. So, before the reaction happens, we have cold magnesium. So I'm just going to go ahead and put, let's say 2 boxes is cold. And then I put it in the flame and it gets hot. Now this is going to be before the reaction. So it's just, it hasn't quite done this thing yet. This is during the reaction. But this is still where it's getting hot, kind of like the flame. But then the reaction happens and it gets incredibly hot. So I'm going to go ahead and give it now 6 boxes. And then finally it'll cool back down to room temperature. So I'm hoping we can agree that the ETH column should do this generally. That we're going to start off with cold magnesium, that's going to turn into hot magnesium, and then it's going to react. And then eventually cool down. Now, we got to decide what to do with ECH. So let's first decide what's going on here. The only time we should have a reaction is in here, because this is like we go from being just hot magnesium to reacting magnesium. So if we're going to change ECH, this is the only time to do it. These other two are not a reaction. And this is probably the biggest problem that I saw on here. This is the only time we change ECH. All right, ECH is based upon a rearrangement of particles. And if this is the only time where we're starting to react, this is the only time that ECH can change. ECH must be the same the rest of the time. So that means here, ECH is not what's causing this change. So what must be causing this change is we must just be putting energy in, which makes sense. We put this thing in a flame. So we're putting energy in. This is the energy that is making the ETH hotter. Similarly, here we're not changing ECH. We're just taking that energy out. In fact, those 4 boxes just sort of disappear. So where do they go? They must leave. But let's look at what's going on here. This energy change, this temperature change must have come from the reaction. These 2 boxes must have originally been in the ECH column. This is energy that has been put in the ETH account that used to be in the ECH account. So here's what I'm going to show. I'm going to show that this thing started off with 3 boxes and that some of those boxes moved over. So now there's only 1 box. Which means if there was 3 boxes here before it reacted, there must still be 3 boxes here. We just can't see them. And if there's 1 box here, there must still be 1 box here. So I would say probably the most helpful thing for you to think about when you're looking at a problem like this, it is admittedly a little bit more complicated, is when does the reaction happen? Because the reaction, when it happens, is the only time we get to change ECH. The rest of the time, all the energy change will be in ETH, and it'll be things going in and out of the system. The only time we move things over is when we're actually doing the reaction here. So going back and looking at our pictures here, the reason why this magnesium goes from hot to incredibly hot is because all of a sudden this reaction occurs. It doesn't get incredibly hot by putting it into a relatively cold flame. All right? This magnesium right here, you cannot get that magnesium hotter than the flame unless there's a reaction. And that is what this is showing. The magnesium gets hotter than the flame because of a chemical reaction. Now, this is where things get a little weird, and I'll tell you generally what I expect, but I'll also say that I could be persuaded if you were to state your case here, because while I'll tell you that in general, we would totally consider this an exothermic process, I could see some other answers that would show me that you understand the material. Why am I calling it an exothermic process? So here's why. I start off with 5 boxes of energy plus 2. So that's 7 boxes of energy before the process, before the reaction, right here, all 7. But then afterwards, when this is all said and done, I don't have 7 anymore. I don't have my original 5. There is more, while it took 2 boxes of energy to get this thing started, we eventually release 4 boxes of energy. Overall, more energy comes out than goes in. If more energy is going out than in, we call it exothermic. So I could maybe be persuaded to accept a couple other answers, but you might have to talk to me about that. Let me know if you're interested in going over a problem, and I gladly will do so. All right, everyone. Do let me know if you have any questions. Hope you have a nice day.